question is, if E and F are the independent events such that probability of E lies between 0 and 1 and probability of F lies between 0 and 1, then we have to check which one of the option is correct. So it is given that E and F are independent events. So according to the independent event property, probability of E intersection F is equal to the probability of E into probability of F. So this is the definition of the independent event. So now we have to check that this which statement is correct. So if we compute probability of E given F plus probability of E complement given F, so it will be, so probability of E given F is probability of E intersection F divided by probability of F plus probability of E complement given F is probability of E complement intersection F divided by probability of F. Now we have probability of E intersection F is this thing. So we'll substitute here. So this is probability of E into probability of F whole divided by probability of F plus similarly here probability of E complement into probability of F whole divided by probability of F. So probability of F is cancelled from numerator and denominator, so it will be probability of E plus probability of E complement, and now probability of E plus probability of E complement will be 1. So this statement is correct. And similarly, if we want to check the statement C, that is E complement and F complement are independent or not, so we want to find probability of E complement intersection F complement. This thing we have to find. So according to De Morgan's law, this is 1 minus probability of E union F, and this is equal to 1 minus, according to the definition, this is probability of E plus probability of F minus probability of E intersection F, and which is probability of E into probability of F. So we have 1 minus probability of E minus probability of F plus probability of E into probability of F. So this is equal to 1 minus probability of E minus probability of F, we can take common. So this is 1 minus probability of E. So this implies 1 minus probability of E into 1 minus probability of F. And 1 minus probability of E is the probability of E complement into the probability of F complement. So basically probability of E complement intersection F complement is also calibrated in the form of independent event. So therefore E complement and F complement are also independent events. So this C is also the correct answer.
So the question is, for a student to qualify, he must pass at least 2 out of 3 exams. The probability that he will pass the one exam is P. If he fails one of the exams, then the probability of passing in the next exam is P by 2. Otherwise, it remains the same. Find the probability that he will qualify. So in the question it says that he must pass at least 2 out of 3 exams. So the total sample cases are when he passed all the 3 exams, pass the exam and then fail exam. So these are the total 8 sample of cases. So now we have to find the probability that he will pass the first exam, that is P. So if he pass the exam, that is P. Assume that he passed all the 3 exams. So the probability of passing all the 3 exams is P into P into P. For second, we will assume that he will pass the 2 exams and fail in the third exam. So the probability will P into 1 minus P. 1 minus P is the probability of failing in exam. Third, first he passed the exam, then get fail, then he passed the exam. So the probability will be P 1 minus P. And in the question it says if he fails in one of the exams, then the probability of his passing the next exam is P by 2. So after failing, if he passes the exam, then the probability is P by 2. Fourth, we will assume fail, then he get pass and pass. So 1 minus P, fail, after failing he get pass, so P by 2, then pass P. So the probability will be PQ plus P square minus PQ plus P square upon 2 minus PQ by 2 plus P square by 2 minus p cube by 2. So p cube and p cube get cancelled. So 2p square minus p cube. So this is the probability. So this is the probability when he will get qualified.
In this question, it is given that a coin has probability P of showing head when tossed. It is tossed n times. Let Pn denote the probability that no two or more consecutive heads occur. We need to prove that P1 is equals to 1, P2 is equals to 1 minus P square, and Pn is equals to 1 minus P into Pn minus 1 plus P into 1 minus P, Pn minus 2 for all n greater than equals to 3. So it is given that the coin has probability P of showing head. So we can say that probability of head is equals to P. So the probability of tails will be equals to 1 minus P, since a coin can have either heads or tails. Now it is given that when the coin is tossed n times, Pn denote the probability that no two or more consecutive head occurs. So P1 will denote the probability that when the coin is tossed one times, we don't get any consecutive heads. Now when a coin is tossed one time, it can either have head or tails, and in both the cases we are not getting any consecutive heads. So we can say that P1 will be equals to 1. Now let us find out P2. Now P2 is the probability that when we toss the coin two times, we should not get any consecutive heads. Now when we toss a coin two times, we can get head tails, tails head, tail tail, and head head. Only in this case we are getting consecutive heads, and in every other case we are not getting consecutive heads. So this will be equals to 1 minus probability of head in both the toss. So this will be equals to 1 minus probability of head is P, and in the second toss also probability of head will be P. So this will be equals to 1 minus P square. So we have proved this as well as this. Now we will proceed to prove that the value of Pn is equals to 1 minus P into Pn minus 1 plus P into 1 minus P into Pn minus 2. So Pn is the probability when we are tossing the coin for n times. So 1, 2, 3, 4 dot 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 n minus 2, n minus 1 and n. This is the nth draw, this is n minus 1th draw, this is n minus 2th draw. Now in the last draw, we may either have tails or we may have heads. But if in the last draw we have tails, then we need to make sure that till n minus 1 draws, we don't get any two or more consecutive heads. That is P n minus 1. The probability that we don't get any consecutive heads till n minus 1 draw will be equals to Pn minus 1. So Pn can be written as the probability that we get tails in the nth draw, which will be equals to probability of getting a tails, that is 1 minus P, and the probability that we should not get any two or more consecutive heads till n minus 1 draw, which will be equals to Pn minus 1. And since we have an add here and here, so we are multiplying. So Pn minus 1. Or this may also be the case that we get heads in the nth draw. Since we have a or here, so we will add. So if we get heads in the nth draw, then we need to make sure that we do not get head in n minus 1th draw. That is, we must get a tails in n minus 1th draw. Also, we need to make sure that till n minus 2 draws, we don't get two or more consecutive heads. And that probability will be equals to Pn minus 2. So this will be equals to probability of getting a head in the nth draw. That is probability of getting a head, that is P. And so we will multiply the probability of getting a tails in the n minus 1th draw, that is the probability of getting a tails, which is equals to 1 minus P, and the probability that we don't get two or more consecutive heads in n minus 2 draws, that will be equals to P n minus 2. And this is valid for all n greater than equals to 3, and this is what we needed to prove.